What if a single beam of energy could erase life on Earth in just a few seconds? Scientists believe this terrifying force already exists somewhere in our universe. It is a reminder of our cosmic fragility. From our vantage point, the silence of space suggests a tranquil universe. But look closer. Space is a theater of extreme, violent forces that redefine our understanding of power. We call them the cosmic killers. Events of such magnitude, they warp the very fabric of existence. Gamma-ray bursts are the most luminous electromagnetic events in the cosmos. Born from the death of massive stars, these phenomena unleash more energy in seconds than our sun will in its entire lifetime. As the star collapses into a singularity, twin jets of high-energy particles erupt from the poles at near light speed. If such a burst occurred within 6,000 light-years of Earth, the radiation would strip our ozone layer in seconds, leaving our planet defenseless against the sun's lethal rays. Deep within the core of a dying massive star, the balance between gravity and nuclear pressure finally shatters. As the core collapses into a dense singularity, it triggers a catastrophic implosion, forcing matter outward at relativistic speeds. The magnetic fields channel this energy, focusing it into narrow, intense beams of radiation that can traverse the entire galaxy. This mechanism turns a singular stellar death into the most luminous electromagnetic event in the universe, a gamma-ray burst. A massive star reaches the end of its life, swelling into a red giant. The pressure of fusion can no longer hold back the crushing weight of gravity. In a violent instant, the core collapses and the star shatters, outshining an entire galaxy. Type Ia supernovae act as standard candles. Because they explode with a predictable brightness, they allow us to measure the vast distances across our expanding universe. The explosion scatters heavy elements like carbon, oxygen, and iron into the void. These are the very materials that constitute our bodies, proving we are truly made of stardust. In the vast, often violent theater of the cosmos, our existence is anchored in a rare state of equilibrium. Behold the Goldilocks zone. Here, the distance from our star is perfectly tuned to allow liquid water, the essential ingredient for the dance of life. Beyond this delicate sanctuary, the neighborhood is often erratic, bathed in intense radiation and cataclysmic stellar events. How have we managed to remain in this cradle of stability for so long, shielded from the chaos of the wider universe? Deep within the wreckage of a massive star lies a magnetar, an ultra-dense neutron star collapsed into a sphere no larger than a city, yet possessing the mass of a sun. Its magnetic field is unparalleled, a quadrillion times stronger than the one that protects our own planet. It is a force that would strip the atoms from your body from thousands of kilometers away. The gravity here is so extreme that it warps the very fabric of space and time. Even light is bent, creating a gravitational lens that reveals the true terrifying density of this giant. Deep in the cosmos, we encounter the fast radio burst. These are intense, millisecond-long flashes of radio energy that sweep across the universe. In 2020, astronomers confirmed that a major source of these signals is the magnetar, a neutron star with magnetic fields a quadrillion times stronger than Earth's. These repeating pulses act as a precise cosmic clock, helping us map the immense structure of the intergalactic medium. Imagine, for a moment, that you are approaching a magnetar. As you cross into its reach, the environment changes instantly. At this scale, gravity is no longer a uniform pull. It becomes a violent tug of war, pulling harder on the side closer to the star than the side facing away. This difference in gravitational pull creates tidal forces so extreme that they tear matter apart. This is spaghettification. Gravity stretches your physical form into a thin, long string of individual atoms trailing forever into the heart of the magnetar. What was once a solid object is now a ghost of itself, dispersed across the curvature of space-time, consumed by the most intense forces in the cosmos. At the heart of every great galaxy lies a behemoth, a supermassive black hole. Our own Milky Way is anchored by Sagittarius A star. Millions of times more massive than our sun, it is the silent engine defining the structure of our home. Here, gravity is absolute. Space and time warp, bending light itself into the shimmering, turbulent disk of an accretion engine. At the heart of the galaxy, gravity creates a cosmic grinder. As matter falls toward a supermassive black hole, it doesn't fall straight in. Instead, it forms an accretion disk, a swirling torrent of superheated gas. Within this disk, extreme friction and gravitational acceleration heat the gas to millions of degrees. This process transforms kinetic energy into blindingly luminous radiation, making these disks the brightest engines in the cosmos. These structures are not merely passive debris, they are active, radiant beacons, signaling the presence of the most powerful gravitational forces in our universe. Deep within the primitive cosmos, we find quasars. These are the most luminous beacons in the universe, fueled by the voracious appetite of supermassive black holes. Though they unleash energy on a terrifying scale, these engines operate in the distant past. They remain safely isolated, serving as markers of an era long before our own galaxy found stability. Their sheer brilliance blinds everything nearby. Yet for us, they represent the sheer chaotic power of the early universe from a safe vantage point in time and space. Over billions of years, the galaxy has been a grand workshop, drifting through the darkness of time. Within the violent death of massive stars, the elements that define our reality are forged. Every atom in your body, the calcium in your bones and the iron in your blood, was crafted in the heart of a star that exploded eons ago. You are a living continuation of this cosmic evolution, a witness to the universe contemplating itself. In 4 billion years, our destiny is set. The Milky Way and the Andromeda Galaxy are on a direct collision course, drawn together by the inexorable pull of gravity. Though billions of stars are involved, space is vast and mostly empty. Most stars will pass by one another like ghosts in the dark, even as their orbits are violently warped by tidal forces. The resulting transformation will merge both galaxies into a single, massive elliptical system, a new era for our local corner of the cosmos. The James Webb Space Telescope has fundamentally altered our map of the cosmos. By peering into the infrared spectrum, it acts as a cosmic time machine, effortlessly peeling back thick curtains of interstellar dust. Where once we saw only opaque barriers, we now observe the violent and beautiful origins of stars and the turbulent accretion disks of the most distant supermassive black holes. JWST's high-resolution infrared imagery reveals structures in the early universe that were previously invisible, providing us with a clear window into our origins. Turn your gaze away from the crushing gravity and the blinding gamma-ray fire. Look instead at this small blue marble. In a vast, uncaring cosmos filled with violent outbursts, life here is a rare, delicate anomaly. A thin, fragile layer of atmosphere is all that separates our existence from the vacuum. Every atom in our bodies was forged in the hearts of dying stars, yet here they have assembled into something profoundly unique: the ability to observe, to wonder, and to thrive. We are a miracle of chemistry, existing in the brief moment between the storms of the universe. Consider again that dot. That's here, that's home, that's us. On it, everyone you love, everyone you know, everyone you ever heard of, lived out their lives. It serves to underscore our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. We cast our gaze toward the birthplaces of stars, the nebulae. These chaotic clouds are not just beautiful, they are the laboratories where the fundamental ingredients of our own existence are forged. Then, the masters of gravity, black holes. Studying these cosmic anomalies challenges our comprehension of reality, pushing the boundaries of physics to their absolute breaking point. And the relentless pulsars, timing the universe with clockwork precision. Every observation we record is a testament to our enduring curiosity. Our wonder is not mere idle daydreaming. It is our primary tool for survival, a legacy of ancient stargazers and modern scientists alike, seeking our place in this vast, electric, and awe-inspiring theater. We must distinguish between the terrifying theoretical threats of our universe and what we have actually observed. Our understanding of cosmic catastrophes is shifting. While GRBs and supermassive black holes pose theoretical risks, modern technology allows us to monitor the heavens with unprecedented precision. We approach these mysteries not with fear, but with awe-filled skepticism. Every year, our knowledge grows faster than our ability to even fully process the data. We began our journey with the most luminous events in the universe, gamma ray bursts. We witnessed the terrifying power of magnetars, with magnetic fields beyond imagination. We explored the explosive end of massive stars in brilliant supernovae. And finally, the gravitational engines that shape galaxies, black holes, and the radiant power of quasars. From the smallest stellar remnants to the largest galactic nuclei, these forces define our violent yet beautiful cosmos. The universe is vast, ancient, and often violent, yet here we remain, a fragile blue sanctuary suspended in the velvet dark. Every atom in our bodies was forged in the hearts of dying stars. We are not just inhabitants of this universe, we are its way of knowing itself. In the grand scale of cosmic time, we are but a fleeting pulse, but in that pulse, we have found wonder, and that is more than enough. If exploring the mysteries of the universe fascinates you, subscribe to Cosmic Mysteries and become part of our journey beyond the stars. A new, mind-blowing space documentary is waiting for you every week.